So this is video 4 in our series of demonstration videos on B04 Introduction to Python, where we're getting used to doing calculations on the console here. So there's a few ways of doing calculations in R. The most basic way is to use the inbuilt functions in there. What we can do is create some variable that we're going to call x1, and it might have a bunch of numbers that we're just going to randomly put in here to have a look at them. And what we can do is look at inbuilt functions that give us information in R, in Python. So what we're going to use is print, and we're going to use x1 to print out. So here, what we can do is just use the min function to get the minimum value in x1. And x1, you can imagine, could be a very, very substantial function. So if we run that, what we can see down here is that we get the smallest value there is 0. And the process finished with exit code 0 means that there's been no other errors found in this Python script, because we get the code 0, which means there's nothing, no other errors. In the same way as min, we have max. Max gets the maximum number. Again, we can find that that's 999. And then the final one that's convenient and inbuilt in R is called sum. So sum adds up all the numbers in our array and gives us that sum there of 1,154. To use other functions, we have to import a package. So to import a package, we just put it up here at the start to import that package we want to use. It's easier to do these all at the start because it's easy to track what packages you've installed and not installed. One of the inbuilt one is called statistics, and this allows us to do certain calculations on x1. So to call this package, we have to first type in the package name, statistics, and then the function we want to use that within that, like mean. So if we run that, that will give us the mean of x1. In the same way, we have mean, we also have median, and that's how we can calculate the median, and we also have the standard deviation, which is also a function you might use frequently in Python. We can also use other packages such similar to statistics. One of those that is useful is called random, which generates random numbers. To generate a random number within a particular range, we can have a print function. So I'm just going to get rid of this print. The function is rand range, if I spelled that correctly. Rand range, all one word. And it takes on a start, stop, and then a step size as well. So if we run that, that will print out a number between 1 and 10 with a step size of 1. So I've got to call the package name. So random goes at the start, and then we're calling the function rand range within that package random. So you can see there we get the number 1 there. In the same way that we have random rand range, we get a random uniform. So that looks at samples of number between 1 and say 5 in that range and gives us a random number within that range. So if we keep rerunning it, we'll find that each time it's a different value within that particular range. So if we change it from 11 to 15, we'll find that the numbers generated are different each time. So those are handy numbers in those two packages. A more powerful package is one we need to install. So to do that, we have to slightly switch screens. I'm going to stop sharing my the PyCharm screen, and I'll share my desktop here. What you want to do is go to PyCharm, you go to settings, then we get a new window popping up. If my computer will respond, there we go. And we go to the Python, you see the Python project, we go to Python interpreter here. You might find that you have a bunch of packages present. You click on the plus key to add new packages, and you type in your package you want, which is NumPy, numerical Python, NUMPY, and then you click install package. And that will access that package, download it from a website and install it on your computer. And then what it should say, if it worked okay, it says package numpy installed correctly, successfully down here. If that worked, then it has worked. It might take you longer on your computer if you're installing it for the first time. Okay, that's great. We've done that. So now we can use that package. So I'm going to go to import numpy and note the difference. We're going to use a shorthand called NP here, which stands for numerical Python numpy. And what we can use then is the functions within that by accessing it in the same way as random as statistics, using the package name NP and then the functions we want to do afterwards. So we could have a function, sorry, a variable called x1. You're going to call the function NP, and we're going to use the array function within there, which takes round brackets. Within that, we put in square brackets. So you could have numbers like 11, 22, -3, 4, -99, -6.2. So we give those numbers there, and we can check that it worked by printing out x1. And note that this is a numerical array, not a list. So you can see that being printed out there. We have those values recorded. So now we can do more advanced things with NumPy. So we can access our elements as before, like element 0 here in our array. We can access the value 11 here. And we can also use a handy function called np.range to print a range of values from a starting point and an ending point. So say 111 to 121 with a step size of whatever we want. It could be an integer step size of 0.8. That will work as well. And what we'll see is that prints out a range of values within there. And that's useful for loops, which is in the next demonstration video. Other things that are useful is that we can print out a range of an empty vector or empty values using our print function, and then we call the function np.zeros and give the number of zeros you want in there. So we could have 999 zeros if we wish, and that will print out that number of zeros. In the same way that we have that for zeros, we can have that for ones too. And that'll print out a whole bunch of different ones there as well. And that can be handy for making sure that we don't have empty values in a vector when we're doing calculations, which can sometimes be useful. So let's let that run. So you can see we have a whole bunch of ones printed out there. Another thing that we can do when we have some vector defined here, np.array, round brackets, square brackets within there, and let's call the values 1.2, -2.7, 3.3, 4.1. So we've our values x1 there. What we can say then, I want within x1, I want to get the values of x1 that are greater than 3. It's a similar nomenclature that we have used before with our print function to access those elements in array that are, say, meet the conditions that we need. So you get 3.3 and 4.1. And what we could do is add on an additional condition there, say, and x is less than 4, to where we're checking that this criteria is met for both items. And of course, I have to use x1 instead of x. So what I need to do here as well is put round brackets around this, because Python is confused by my abbreviated versions of shorthand. So we're saying x1 greater than 3 and also less than 4 within our function there, and now we see that it worked. So I needed the round brackets in there to get it to work. Before it didn't work because it found it ambiguous. So that ambiguity is something the computer can't handle, and hence you saw that it gave me that peculiar error message. We can also access elements within X1 using a shorthand 2. So say we want the final two elements. And next we can say from element 2 onwards with just 2 colon. It's just a shorthand to select those elements only. So we see that this prints out. Oh. So let's try this again. So colon 2 should print out the first two elements in X1. Okay. I printed out there. Oh yeah, my mistake. I had two square brackets there. So that prints out the first two elements now. Yeah, 1.2 and minus 2.7. And then we can print out the last two elements as well. So we see there 3.3 and 4.1 printed out. So this is kind of a shorthand for accessing element components in R, in Python even. We can create another element like np.array, and we could add things into there. So let's say we have numbers 99, 88, 77, 66, and 55. What we can do is concatenate them. So our function is np.concatenate, if I can spell it. And we're concatenating y1 and x1 together like that, and putting in a round bracket, and then we run that. What we see is that it has put, should have put y1 first. So what was incorrect here about a function? I think I need another set of round brackets. So there it works. So the first set of round brackets was for the function np.concatenate, and then there was another set of round brackets just for these variables only. So that solved that issue. So now we see 99 down to 55, and then 1.2 to 4.1. If we switch this around, x1 comma y2, you see these are also that the new array order is in that manner. And as you can expect, we could call it a new vector called set1, np.concatenate there, and then we can print set1 out. So you can call that as a new vector. I guess the final point is that we could make these vectors more complicated. So we can make multi-dimensional vectors, and there's an example of that in our vector A4 in the worksheet. So if we just paste that in there, what you see, this is a 2D array. So it is two, we'll call it 3 vectors inside here. So A4 is now a 2D array with 3 elements of 3 elements for each element. So we can say, we can ask then, what dimensionality does A4 have? We can check the shape of it, A4.shape, and ask, what is its shape? So you see, it's a 3 by 3. We can add another element in here so we understand the orientation better. So now, does it change from 3 by 3 to something else? We can see now, if it runs, it's changed to 3 by 4. We can also have other functions like the size of A4. It's 12 elements in total. And ndim is the number of dimensions for our more complex matrix. So you can see there, it's got 2 different dimensions. If you looked at the previous vectors we had, they were more simple. They just had 1 dimension only. What we can also do is reshape A4 as well, using the function reshape. So note that we have 12 elements here. So if we want to reshape it, what we're going to have to do is use 12 elements. So we could do 2, 6. Oh, 2, 6 to create a 2 by 6 array out of this instead. So you can see it merges the first two, 3, 4, 5, 6, 7, 8, and then the other half goes from 9 to 14. If it says 6 by 2, as you can guess, it's going to make it arrays 3 and 4 5 and 6, 7 and 8, and so on, which you see there. We could convert it into 4 by 3, which means it's going to be 3, 4, 5, 6, 7, 8. You can see down here. And then we could even do it into a simple 12 by 1 array as well. So you can see there, we now have 12 arrays, each which a single element, or we can do 1 by 12, which is our more simplistic arrays we had at the start, which is just a single array with 12 elements. So that's how we can actually manipulate vectors in different manners if we wish to do so using the numerical Python functions, which are very handy for calculating things in Python. So that concludes this video on that.